Well, I'm making a little experiment to see if I can get rid of these diode clumps that I have on these boards. I'm using these diode clumps to collect positive and negative voltages in either direction and turn on the relay. So what I've put together is a transformer going through a rectifier. So what we're coming out here with is DC in one direction. I'm taking this DC to a step-down buckboard, and I'm turning it down to 3 volts, which is about what the relay can handle. And then I'm running it through a smaller rectifier, and I'm putting that DC voltage through the AC inputs to see if the positive will light up this LED. The LED is connected to the positive side of that rectifier. So as I plug in the positive or the negative side, you can see, bingo, the LED fires. Now I'm going to switch these wires from positive to negative as if I was translating the engine or the motor from forward to reverse. So now the polarity is going in the opposite direction through that rectifier, not a glob of diodes, and the light comes on. So I'm still getting the signal back that the motor is turning regardless of the polarity, and I'm getting it through a very small rectifier. So that's going to simplify this mess here from 4 diodes and all that wiring and everything that goes with it to a simple piece of gear that solders in, and boom, you're done, which I think is going to work out great because I'm running out of space, and building this is a nightmare. So I just have a few of these small ones. This one has the leads off, but I can solder it in, I guess. But I only have a few of these, but if this works like I see here, then it'll work on the engine. I'm going to do a test on the engine, and then we should be good to go. And I'll go ahead and replace the glob with this, and I'll have a better package for fitting on the engine and fitting inside the engine. That's the whole objective, is what does it take. So I do these little experiments which are pretty painless, and if something blows up, it doesn't matter. It's spare parts basically. But if I can simulate the exact same conditions and then test the component and that make it work, then I feel comfortable that this scenario is going to be just fine. So I'm going to have a pair of rectifiers. One is to step it down, and the other is to limit that. And then the third one is simply to take in the 2-pole DC polarities and convert it to 1. And that seems to be doing the job, so I'm done. All right, I'll post this for your interest. Not a train, but it is a train. But anyway, later. Oh, the printer, if you ask. Look at that detail on that part. I don't know, you may not be able to see, but the part is coming out beautiful, I have to say. Everything is working. I put in the extra fan. You can see on the right and the left of the nozzle there's two red things. Those are ducts coming down from a fan blowing cooling air on the part, and that seems to have made a big help, along with some of the other updates that I've been doing this couple of weeks. You know, when you go to Clipper, you have opportunities, and it just offers you so much more capability. Get that light up. That shows you the part that you're going to print, and it gives you the temperatures you're at, the Z height, your speeds, and your elapsed time and how much time is left. I got 10 minutes left on this part, and you can make some real-time adjustments if you want to. So you can see up there 80% complete. Okay, we're off and running. Multitasking all the time. Later.